Today on Mining Journal and Mining Magazine's 2021 Tailings Program, we'll be speaking with Colleen Crystal, Principal Geotechnical and Tailings Engineer with SRK, a leading global mining consultancy, and Ron Kelly, Founder and Director of Terra Nova Technologies, or TNT for short, an equipment solutions provider for material handling. You both touched on it a bit there, but if you could talk maybe in more detail about what your clients are discussing or worried about, or their pain points in regards to tailings management. Ron?
Sorry, go ahead. Sorry.
Well, I think obviously some of the concerns is the overall risk of the slurry tailings facilities that we've seen and the failures we've seen in the recent past, but over the years, really, it's been going on for some time, and I think the other main thing besides the risk is water. Water's become a very, very valuable resource, a very costly resource, and something that's critical to any mining process.
Yeah, I would tend to agree. The recent failures have made it very clear to the industry, designers, owners, operators, underwriters, that we all need to be pursuing a pathway to safer, more sustainable tailings management. This transfer of risk is not going to happen anymore. We've got to, as designers, support the owners in owning their own risk. I think one of the biggest challenges there is recognizing, as they look at their portfolio of dams through databases and risk management frameworks, recognizing that conformance or concordance with the global tailing standard is going to be a challenge for several, if not many, of the dams in their portfolios. These may not meet all of the prescriptive requirements of these new standards. And so we definitely have to be pursuing and pushing on alternate new technologies in the future, just doing it a different way. The alternative technology is, as Ron noted, yes, water savings, reduced footprint, ability for concurrent reclamation. CapEx costs are really not the issue. However, it's the long-term OpEx costs. And really that, as a design engineer, where it comes down to that not all of our pre-feasibility and feasibility studies for filtered or alternative paste, thickened, cyclone separated tailings go forward into design, construction, and operation because of the sort of juggernaut of that challenge of solving the OpEx costs. But we all, I think, as an industry, recognize that we need to be doing something in a different way in the future when we look at this portfolio of dams.
I'd like to ask you both about the solutions you provide, to go into more detail about the solutions you provide, but just on the back to the problem there for a moment, on the topic of water, which you both mentioned, and we hear it a lot from everybody. Is it something that's sort of a bigger and bigger issue recently? I mean, it's an obvious issue with tailings, but is it something that's becoming a bigger issue because of environmental or more mines being built in, I guess they call it water negative areas, or is there a trend there?
It does. I think it does depend where you are. I've got filtered tailings, or SRK's got filtered tailings projects in Australia, South America, some of South Africa, some very dry and arid regions, also in some very wet regions. So it really comes down to the cost of water, the water balance, whether it's a positive or negative water balance, but it can be one of the factors that brings the overall balance of going with a filtered tailings or alternative project into the realm of feasibility when you start looking at the life cycle and holistic costs, including risk costs, but water costs, closure costs, risk costs. These are all part of the trade-off on whether or not we can afford to go with something that's generally a higher cost option.
We see on the bigger concentrator type projects or even heap leach projects that the water side of the project becomes a vertical package. It's so big. So you look at where we get most of our copper, a lot of our copper in South America. There's restrictions on drilling wells and lowering water tables to the point where they have to build desalinization plants. They have to pipe it up hundreds and hundreds of kilometers. And, with a slurry pond, there is a lot of evaporation, especially if you're in a desert area. And you have to replenish that water. So it is a question of cost. And again, I think all those costs need to be looked at when we look at alternatives to make sure that we're not assuming a low OPEX or a low CapEx cost on slurry when, if you incorporate some of these other costs, it may not be quite as low as we think.
Now if you could both talk about the solutions that you provide in regard to these problems. Colleen, would you like to start?
I think I'll just keep it fairly general in terms of time, but SRK is involved in design, operation, as well as a number of feasibility, pre-feasibility studies worldwide on all continents. We've got cold weather options for filtered tailings going on in Europe and Canada, hot and dry tailings options in Chile, Arizona, Australia, and South Africa. So we have a number of small tonnage projects in that 45 to 5,500 tons per day. We've got some demonstrated experience on 30,000 ton per day projects, and we're currently involved in some that are pushing limits of 100,000 tons per day and looking at alternatives for those. So no, there's not one specific project. We've got quite a few on the books. But I think that just speaks to when I personally started in looking at this arena of non-conventional options in about 2011, it was sort of a way out there. And now it's become a much more mainstream. Everybody's looking at it. Everybody's considering it. And I think it's because of the projects that we've successfully demonstrated it can be done.
So TNT has, like I said, worked and had a particular niche in heap leaching. And we believe that there's a lot of similarities between stacking dried or filtered tailings and heap leaching. And I think whether it's our equipment set or somebody else's equipment set, I think there's an awful lot of application of technology and things we can learn from that industry. We currently have an operation in Saudi Arabia that's stacking about 35,000 tons a day. And that particular need right there was they're in a flat desert right by the ocean, and the material had to be stacked up. And it's been running since 2011. We're putting in our third extension to the pad. And it looks like a heap leach. If you look at it, it's white, but it looks like a heap leach pad with the different lifts and the different layers. So I think getting to the challenge and scaling that up to 125,000 tons a day is certainly doable. But I think it's going to take an all-out effort of the client, the geotechnical and rheology water people like SRK and others, and companies like TNT and other providers of material handling equipment that are focused in this area.
And in your experience with filtered and alternative tailings technologies, what are some of the challenges that you've had in implementing these?
I think it depends on where you are. There is not one size fits all. So it is very project specific. You're going to have challenges in regions like Brazil with high seismicity, canyon fills, stability, et cetera. Still with filtered and alternative tailings technologies. You've got different challenges in arid regions. It comes down to still getting the basics right. Good fundamental engineering, good design, understanding how your material is going to behave when you put it into a landform, and still pushing on designing a robust, reliable, and stable landform that basically meets the global tailing standard. It's not a one-size-fits-all solution to go filtered or tailings or dry stack, and then all of a sudden all of your problems go away. There will be dry stack failures in the future if we don't apply good fundamental engineering and soil mechanics to these facilities. We also have to build them appropriately. So all of the same challenges with conventional facilities we are having with filtered and dry stack tailings facilities. So basically, it comes down to the good engineering across the board, good design, good engineering.
And I would add to that, Colleen, that the clients that we talk to, we start talking about 100,000 tons a day. And our systems traditionally do 100 to 150,000 tons a day. But in a mill application, it needs to be continuous. You don't shut off a thickener or a mill on and off. It's not a light switch. So you have to have a redundant system or a bypass. Or alternatively, if you already have a slurry system and you want to convert to a dry system, your bypass can be the slurry or your bypass can be the dry stack, however you'd like to do that. And I think it's worth mentioning that there probably are some alternatives when people discover larger ore bodies. They don't want to go through the permitting process or the cost of raising a dam. Perhaps there is alternatives where they can do a dry stack on top of an old area where they've slurried, and they can still get the additional ore reserves that they found without going through the cost of raising the dam. So I think there are alternatives. There's also reprocessing alternatives. If you have some older tailings that have ore values in them, that could be reprocessed and stacked and actually create a slurry area, if you will, within the pond. So
yeah, I think I just want to add, it does come down to a stacking plan to put this material in a self-supporting and a stable landform. You know, how we do that is a challenge at the higher tonnages. One thing I've said in prior presentations is it really depends. You've really got to understand how the lift below reacts to the next lift and the loading above, as well as loading from seismic events, rainfall, and all your challenges. So this is one of the reasons that we really think it's going to take a multidisciplinary team to solve the challenges of a safe and stable landform with a cost-effective stacking plan. And we've got competing interests and competing goals sometimes, but it's going to take a multidisciplinary team to solve it at the higher tonnages, to understand the problems with multidisciplinary experts. And that's part of the reason that we like the idea of getting together with owners as well as providers of stacking equipment to do a little more R&D. We've got to put some money into the R&D to take us from safe and stable stacks of 4,500 tons per day to safe and stable stacks of 100,000 tons per day.
SRK and Ron Kelly, TNT, thanks for your time.
Thank you.
Thank you very much.
Okay.